Hello, my name is Tui Puliu, and today's lesson is going to be basic use of a laser level. Our objectives today are going to be to identify the uses of a laser as it pertains to heavy equipment and construction, discuss safety precautions as it pertains to a laser, demonstrate how to use a laser. So we're going to set up a laser and use one, and then use a laser to make a small topography map. Getting right into it, what are some of the uses for a laser in construction? First one is to determine the high and low spots that we would have on a piece of ground. So idealistically, some places we would want level or to have a certain pitch, and the laser level would allow us to find out where those points are in order to be able to add or remove material. Okay? We could create a topo map, which would mean we would actually plot those points on a grid, and that layout would kind of give an idea to where we need to grade or where we need to add and fill. And then to make our grade levels accurate and finished. Okay? So starting right into it, getting right into it and setting up our laser, the first thing we're going to do is we're going to spread the legs of a tripod. Now I've already done that, kind of get it at face level. I don't have to have this real accurate for reasons you're going to see here momentarily. Okay? Next we're going to place the laser on top of the tripod and screw it in. So this is the laser level base itself, and we'll take this and just screw it right in here. Now, we do want our laser to be level, but the wonderful thing about this laser is that all we have to do is push this button, our power button, and the laser will self-level itself. So right now it's going through the leveling process, and as long as we're kind of eyeball close on our tripod, then the laser will take care of the rest. Okay. Next we'll have to take our sight rod and put it on a specific point. So in order to be able to get my reference point, I would choose a point on the land where I would want everything to be leveled in according to that, plus or minus. So I've got my sight rod here. I've got my receiver that's already on there. And I'm going to move my receiver up and down until it reads that it's going to be level on the receiver. And it will let me know that. There will be visual and audio cues in order to be able to let me know if this is level or not. So they are pretty identifiable, as you'll see. And I have it on the quietest setting right now. And right now, visually, it's telling me to go up. There's an arrow that's on here on the visual reader. If I were going to go too high, it would tell me, there would be an arrow that tell me I would need to come down. And then once I get a straight tone, then I've found my reference spot. Okay? Now depending on where you want that reference spot, that's where you would set that initially. Now everything that we have in relation to that will either be above it or below it. So after we do all that, then we'll move to the next point of where we wanted to plot our grid or to find out what kind of slope that we have on certain things, but it's all relevant to that reference point. Okay? So this is just kind of another illustration. It's kind of the same thing that we just did, but an illustration of it. We would set our laser, and the height of the laser really doesn't make very much difference. Because when I put my sight rod down, my receiver on my sight rod, this is where I'll find my reference point, and it has to deal with where the location is on the ground. Okay. Then for every point that I plot after that, it will be a vertical distance of either plus or minus whatever your measurement is. Okay. So for instance, if this point were to sit 2 feet higher, it would just be noted as plus 2 feet. Okay? And the same in retrospect, if the next plot were to be if the next point were to be plotted maybe downhill from this, then this could actually be a negative number. So if it's set down -2 feet down from it, then you would just notate that the next point was a -2 feet. Okay. So now we're going to make a small topo grid or a topo map. And what it does is allow us to see a certain plot of land and see what the difference in elevation is as it is relevant to a certain point that we'll pick. Okay? So on the worksheet that's provided, we're going to show you kind of what we're doing here. Always be safe whenever you're using your laser. It's not that dangerous of a tool. It's not a power tool. But there can be the potential for the laser, having direct exposure to the laser in your eyes. So you never ever want to look directly at the laser. It's okay to be above it or below it, but you always want to you always want to make sure that your eyesight is above or below, not directly across from the laser. So we've set our base, we've set the receiver on the survey rod at the reference point. We move our survey rod to a desired area, and then we would move our receiver up and down in order to be able to find our reference point, and then repeat in a grid pattern. So after we found our reference point, we'll repeat it in a grid pattern. So what we're going to do now is actually make a topo map. And what I have set up here is 9 quadrants. And going from top to bottom, left to right, this will be quadrant 1, quadrant 2, quadrant 3, quadrant 4, quadrant 5, 6, and so on. Okay? So our reference point is going to be quadrant 9. So we'll start on quadrant 9. Starting on quadrant 9, I will get my measurement. Now, I've gotten my measurement and I've found that reference point. So when we move to another quadrant to check the measurement against that quadrant, then we would notate that difference. So in this case, what I've done with the students so that they can touch and feel the measurement is I use it in measurement of books. So in quadrant 1, after they were to level it, they can see that the quadrant level on number 1 would be +2 books. Okay? So if this was 1 book, everything is set to this reference point. This would be +2 books. So in quadrant 5, for example, quadrant 5 actually sits below quadrant 9. So that would be written in -1 book. So and the same goes with whatever measurement we're using. So if it were to be inches, it would be plus or minus inches. If it were to be feet, we'd go plus or minus feet. But everything is based on that reference point. So a quick review.
Courtney Baumgartner to the front office, please. Courtney Baumgartner to the front office.
After our wonderful announcement there. Lasers could be very useful in determining the grade and the level of an area of land.
Terrence Bruner to the front office. Terrence Bruner to the front office.
Another announcement. It is important to always keep eyes out of direct exposure of the light. So I want to make sure that I'm above or below the laser as far as line of sight. Never want to be directly across from it. Set the base, find the reference point, survey predetermined points, plus or minus elevation as it relates to the reference point. So after I found my reference point, everything will be above or below that. That's it. Thank you.